questions or whatever, I will edit you out. Um, so feel free to ask questions like normal. So catching up, some of you did a ton of work over the break. I know it's a challenge, and I would just encourage all of you to keep moving forward and keep doing your best. Um, I think part of our challenge, especially with distance learning, that some of us are facing, probably even for the first time in our lives, is you're a good student, or you might say used to be. You're still a good student. Okay, don't sell yourself short. It's just now you've been facing difficulties you've never faced before. You're overwhelmed, and it's just hard to know what to do or how to get through it. So I wanted to encourage you to keep going, okay? And especially now that you've had a little bit of rest, a little bit of a break, um, kind of jump back into it and get going. So here are two quotes, and I want to hear what you think about this in the Pear Deck. You can tell me. But the first quote is, "Some things are worth doing badly. And don't let the perfect be the enemy of the good." Now, the second one is a quote that I actually have heard in the military, but the first one is one I heard recently, and I thought it was really, really well said. Their context was brushing your teeth. The benefit of brushing your teeth comes not in how well you brush your teeth, although it's important, but it's actually almost as important, if not more important, that you brush your teeth every day. So brushing your teeth is something that is worth doing badly. Okay. So what do you think about those two quotes? What do you think about those two quotes in the context of trying to turn in work and catch up and do work in school? What do you think? Tell me in the Pear Deck. I'm gonna give you about a minute and a half, 2 minutes to write something. Some things are worth doing badly. Don't let the perfect be the enemy of the good. What do you think about those quotes? Tell me in the Pear Deck, please. Excellent thinkers. I appreciate what you're telling me about these quotes. Maybe you're all caught up, but I still want to hear what you think about those quotes. I mean, it's okay if you don't like them. That's okay too. What do you think? Oh, wow. That's also a really good point. On one hand, I don't want to dwell on this too much because we got some physics to get to, but this is really important to think about. So I'll give you about 30 more seconds. You know what, Diana? That is a great statement. I don't know. I will try to do something. Okay. I will certainly work hard to bring that back next quarter. I know that doesn't help you per se, but I like Motivational Monday as well. All right. I hate to pause you if you're writing a deep thought, but I'm going to, because I want to share, and I want to share what some of your classmates are thinking on this. Okay, so let's do that. That'll help me. Okay, catching up is worth doing badly because you can get a better grade. But don't try too hard to do everything because you either burn yourself out or end up not even doing it. Okay, excellent. Well said. It's worth trying to get the work done because it shows that you're trying and that you are putting in effort. So, and that's probably part of this whole deal is there are some of us that maybe haven't had to work super hard, or the how the work is done is so different that it is a challenge. So effort is important, and how hard you're working, and I recognize it. So keep working hard. Small assignments can be worth doing badly if you need to work on an assignment that is worth more if you don't have much time. So it's partly about prioritizing assignments. Focusing too hard on an assignment, wanting it to be perfect, because I'm a perfectionist, and it took me a long time in college to realize not everything needs to be perfect. Yes, there are some things that need to be better done than others, and we need to always do our best that we can. But if you spend too much time on one assignment trying to make it perfect, then you miss out on others as well, including other classes. So it's more important to do something than not to do anything. I think the quotes mean that you don't always have to strive for perfect scores. And as long as you understand what your instructor is lecturing on, you will be fine. And I really, this is part of a big movement. I know teachers all across Steele are talking about this, but is grades often impact, grades actually usually work counter opposite of actual learning. And so how do we focus on learning and get the grades out of the way? So it's hard to do. First quote is that, like, at least turn something in rather than just not doing the assignment, because something is better than nothing. And that's absolutely true. And it doesn't have to be perfect. Do your best, get it turned in. I would like it to be your best, okay? But I also want you to realize that sometimes good enough is good enough, okay? I really like this second statement here, because this is the extreme. If you take those quotes too far to the other end, this would be my argument against those quotes. Don't do it halfway just to do it halfway. Don't fail to fail, but don't try to be too perfect. Just do your best. So the goal should be about learning and not trying to fill all the nooks and crannies and making every little I look perfect, okay? Now, if that's your best, then yeah, okay, shoot for it. But sometimes trying to be perfect gets in the way of other things. And I really like this. Tells you not to obsess over doing everything perfectly and getting stuck, because that's what happens. You try to do everything perfectly and you wind up getting behind, not being able to do it perfectly. You get frustrated. Then you start getting, and it just snowballs. Okay. Sorry, Ethan. Yeah. We need subtitles for this. So I am recording a video, so I'll put it on YouTube, so there will be subtitles later. So I really want to encourage you. We have 3 weeks left of school. We're going to talk about the calendar and look at that. Try to catch up, do something, get it turned in. Because if you do nothing, I am giving you a 50% for the assignment. That's just to make it so that you have a little hope. If you do turn it in, you can get to a 70 pretty easily. Okay. So you don't have zeros in your grade book. There are no zeros. There are only 50% if you are missing something. And if you turn something in, it magically turns into almost full credit, if not full credit, and your grade will go up. So don't stress about it. Do one little thing at a time. You brush your teeth a little bit every day. Do one thing, and I think you will see some progress, especially for those of you that are stuck. All righty. Let's talk about our calendar. So this week we're going to be talking about charge and the atom. Next week we're going to talk about, we're going to take that and go from static electricity and then start talking about current electricity. We're going to talk about electricity, circuits, electrical circuits, and electrical power generation. And then last week we will finish with a very, very brief tour of magnetism and electromagnetic induction, which is an amazing principle. It is probably one of my favorite topics in all of physics. I took 2 classes in college on just this. Okay. So it's a pretty deep topic and we're just going to spend 3 days on it. All right. What I really want to point out on this is today is your work day to work on your final draft. It's not actually due until Friday. Let's see. On tomorrow, you're going to do static electricity video notes. And then next week, I'm going to introduce how I want the video to be done. It'll be very similar to last time, but I'm going to add a couple of things that I want you to try to do to make it better. and that won't be due until the 15th. You will have your final quiz, which will just be on electricity and magnetism stuff. It won't be over the whole year, so don't worry about that. It'll just be over all this stuff, and then most of it will be vocabulary. Okay, and there will be a feedback and survey and a little bit of a reflection for you, but a lot of it will be, we've done distance learning. This is the first time we've ever done a full class with distance learning. What things do I need to know about? What are some things you need to think about? Because even though next January, the plan is still for us to go back to school, a large part of our school, even though we will be in person, will still be online stuff. Okay, so I'm going to need some feedback to make some changes to make things better. Friday is a planned catch-up day. I'm not going to assign anything for Friday, so that you have that last day to catch up. Friday the 18th is the last day of the quarter. Quarter 2 ends. Okay. Now, I'm going to start trying to post the weeks, the next 2 weeks. I'm going to try to post those as early as I can. So once something is posted, let's change colors here. Once something is posted, you can start working on it. Don't skip around, do it in order, because I've programmed it so that one thing leads to the next thing and it makes sense that way. But once it's posted, start working on it, get it done. There's a couple people who have already finished this entire week. Okay. So once you see it posted, get it done. That way you don't have to worry about this last day of the quarter because you're already done. Okay. And if you get done early, you get done early. Okay. So don't wait for the assignment date to do it. You can. They're assigned on a date for a reason, okay, to help space things out. But sometimes I know how it is. You're on a roll and things are just working and you're like, okay, I want to do the next thing and it's not posted. So I'm stuck. Okay. So I'm going to try to get things posted so you can get things done. Because I also know there are many of you that need to catch up as well. So I would say you should, in your planner, you should be picking, what am I going to do that's extra each day? If you do one thing each day, and I'm just talking like on the days we have Zooms and stuff, or maybe you do it all on Monday and Sunday and Saturday, but if you do one thing each day, that's literally 18 days. That's 18 assignments that you could work on and get done. So if you're missing 18 assignments, you could get those done by the end of class. I guarantee you, if you turn in those 18 assignments, your grade will be much higher. Because if you're missing 18 assignments, your grade is probably close to the 50 or 60% mark. Okay. So if you do one little thing, do something badly every day, get it done, get it turned in, you might be in good shape. Okay. If you have any questions, send me a chat. I will make this student pace later so you can come back and put this in your planner if you need to. So let's talk about the atom. So this is a review of the video notes. Before you drag anything, let's just review a couple things and then you can drag to your heart's content. So first thing is we've got a hydrogen atom, which has a proton. So protons are positive, okay? And then we have electrons. So we have our electrons, which are negative, and then we have our neutrons, which are neutral. So what I want you to do right now is drag the red dot to where you think the proton should go in this drawing. Where does the proton go for this drawing? Go ahead and drag that dot. Drag the red dot to where you think the proton goes. In the Pear Deck, drag the red dot to where you think it goes. And if you're not sure, you can look over at the Paradex screen. You should be able to leave the dot there and then go grab the other color and drag it to the right place. So we're going to focus on the red dot first. Where does the red dot go? So I try to stick with those colors. Those are actually, there's not a written rule that it has to be that color. But when we do our PhET simulation, the protons are red, the electrons are blue. Most simulations do positive charge as red and negative charge as blue, but it's an unwritten rule. There's no hard and fast rule. So be careful when you get into another class, make sure that you know what color they're actually using. But for this class, I'm going to try to always make protons red, electrons blue, and neutrons gray. My pen is not gray, so it's brown in color, but yeah, try to get as close as I can. All right, so protons go in the nucleus, so your red dot should be in the center of the atom. So your red dot should be in the center, which most of you have. So your red dot should be here in the center. Okay. The blue dot, where does the blue dot go? If you haven't dragged your blue dot, go ahead and do that. Looks like most of you have, and you are correct. It should go around the outside, around the outside. 2 electrons go around the outside. Okay. Little Slim Shady in physics version. Okay, so here we go. Where does the neutron go? The gray dot. The gray dot actually goes here in the middle as well. So excellent. Looks like most of you got it. So we should have protons go in the nucleus, electrons go around the outside, and neutrons go in the middle. Now, one thing I want to make clear is in biology, we use the word nucleus, and that nucleus literally is like the center of something. So, but the nucleus of a cell in biology has stuff in it. It has DNA, and it has all these things going on. And there's like a membrane surrounding the nucleus that separates it. There is no other like coating or anything that separates the nucleus from the rest of the atom. The particles just sit there in the center, okay? And then this space in between is empty space. Completely empty. All right, so let's try this now. You're going to drag the negative to where the negative should go. I don't know if you can drag more than one negative. I think you can only drag one. So just drag one negative to the right place, drag one positive to the right place, and then drag a 0 to the right place. There are multiple correct answers. So go ahead and take a shot at that. Where do the negatives go, positives go, etc. Looks like we're getting it mostly. Electrons are negative, protons are positive, and neutrons are neutral. So it's more about, do you know where the electron is? Okay. So this should be negative. That's the electron. This one could also be negative. Okay, negatives go in those 2 places. So if you don't have it, put it in the right spot. Protons, positives. This is a little hard to see, but the red things should be the positive. So you have a red thing here, and you have a red thing down here. So that's where the positives go. Okay, and the N0, which is the neutron, no charge. See that little silly way to remember that? It says no charge. So 0 charge is the gray thing. Okay, so 0 goes on the gray thing, which is here. So make sure you've got it correct. So we should have negative, positive, 0, or positive, 0, and negative. So those are negative. The reds are positive because they're protons, and the neutrons have no charge. In chemistry, there's like a ton that I want to talk to you about with the atom, because the atom is one of my favorite topics to talk about, but we don't have time for that. So what we're going to do is we're going to move on to, you're going to talk a ton about the atom in chemistry, because that's what chemistry mostly deals with, is the atom as a building block for chemical processes. So we're going to focus on more of a physics aspect of it, which is the idea of charge. So protons and electrons carry charge, and but let's take a look at how charges behave. So there's a law of charge. Law of charge says like charges repel and opposites attract. So you should have heard that before. And what we're going to do here is I'm going to draw one first as an example, and then you can make your own drawing and draw the rest. So when we draw these, when I ask you to draw, which direction will the charges move? You should start at the center of the atom or the center of the charge and draw the direction from the center. So these are like charges, so they're going to repel, so they're going to move in this direction. So start in the center of the charge and draw going away, okay? Because those are like charges. Like charges repel, start in the center and draw away. Opposites attract. So we start in the center, but they're attracting. So we're going to draw it like this. Start in the center, draw in the direction the charge will move. Okay? So that's how you do that. So now I want you to try on your own to do the bottom two. Now your pen tool is probably pretty like a fat pen, so it's pretty hard to draw some of this. You can change the size of your pen. So if you can make it smaller, make your pen smaller or thinner, it'll make it a lot easier to draw these arrows, okay? So see if you can find on your screen how to make those arrows smaller, and I think you will be happier with the drawings that you're able to do. Good, looks like most of you have figured it out. Looking good, looking good. Oh, got a couple of mistakes. Okay, I will remember, always start in the center of the charge. Start from the center and then draw the arrow away. You always start from the center and then move the arrow in the correct direction. Okay, these little gray boxes are, we're pretending like the other gray boxes don't exist next to the other gray box. Some of you are trying to connect this box with this box. No, this box is by itself, okay? So when we look at this gray box, it's only this gray box. We don't care about the others, okay? And then vice versa, if we're looking at this box, we're only looking at this box. All right, let's check our answers here. So like charges repel, so the negative and negative. So we start from the center and we draw away. Start from the center and draw away. Opposites attract, start in the center. This is kind of hard because they're close together, but we start in the center and they go towards each other. Okay? Now notice, what am I not doing? I am not doing this. I'm not doing something like that. Okay? I'm always starting in the center and drawing the direction the particles are going to move. Now, by convention, we could say these arrows actually represent two different things. They could represent the velocity of the particle, which direction and how fast the particle is moving, but they could also show the electric force. And then, so tomorrow's video notes, you're going to explore the electric force. So that's what these arrows are actually showing you, is which direction the electric force is pointing, okay? We could also change the label from proton to Q. So Q is our label for charge, and this could be Q1, and this could be Q2. Q1 and Q2. Okay? So that's just a preview of what you're going to see in your upcoming video notes. All right, let's try another set, and you're going to try these on your own, but I'm going to do one for you. So same thing. We're only considering the gray box by itself, and you're going to draw the arrow. So let me do the first one for you. Positive and positive, opposites They're not opposites. Like, repel. So we start in the center and they're going to repel away from each other. Like charges repel, but notice which direction I drew the line. I drew the line in the opposite direction of the other particle. So for this red object, where's the red? It's down here. So it's going to go away from that particle. So it's going away, perfectly away in the opposite direction. Okay, so try those other three for me real quickly. Draw your arrows. Opposites attract, like repel. Opposites attract, like repel. Draw those for me. Good, good. Doing good. Looks like most of us have found the ability to change the size of our pen. Good. And check your answer. I've drawn the correct answers. Yeah, okay. Make sure. Make sure I didn't make a mistake. So if you have not done it correctly, correct it, make it correct, okay? And check your answer, and I will move on in about 30 seconds. So check your answer. This is how they should look, and we will move on shortly. So that was the direction that the particles would move. So what you basically drew was the electric force, okay? What direction is the force causing the particle to move? So now we're going to draw the field line. So this is different. So don't draw anything yet, okay? So there's a couple rules that we need to make sure that we're clear on. So let's do that. Let's lay down what the rules are. So the rules are this. Field lines are basically, we're going to pretend like we take a charge. So let's just take a look at the positive here on the left. This positive charge. A field line shows us what would happen if we place to a positive charge, if we place it next to this charge. So if I place a positive charge, if I were to place a positive charge here, let's change the color. If I were to place a positive charge right here next to this, what would happen to this charge? It would move away, right? Okay, so that's what the field line actually represents. When we draw the field lines for a positive charge, we draw them away from the positive. And we're just assuming, we're going to pretend right now that this negative isn't here, okay? So they would move away from the positive charge, because if I put a positive charge right here next to it, that's what would happen. So that's what a field line shows us. So if I put a positive charge next to the negative, which way would the positive charge move? The positive charge would move towards, sorry, wrong way, towards the negative. So when we draw field lines, we are basically just showing which way a positive charge would move. Okay, so let's write down this rule here. And let's see. Nope. Let's select the correct text box here. Okay, so positive field lines move away. Negative field lines move towards. Okay, so we're going to add to this in just a second. But this is all based on this idea that what would happen if we added a positive charge to the situation. Okay, so now we're going to do this with a system of charges. We're going to have multiple charges. What happens? So it's kind of the same thing, but it always goes from positive to negative. And what happens is, as this field line goes away from the positive, the negative bends it towards the negative. So positive to negative. And then we have our other field lines. Okay. Now, you could almost draw this for any drawing, but without the arrows, it's meaningless. So which way would the positive charge move? It would move that way. It would move away from the positive towards the negative. Be careful, because you get to seeing this circular thing and you want to draw on it. Don't draw on a circle. It goes away from the positive towards the negative. And you'll notice most of the time when I do this, I draw my line in the direction it actually goes. Even if I haven't put an arrow on it, I draw my line in the direction it goes. So like this negative charge, when I draw my lines, I will draw the line as if it's moving towards. When I see my positives, I will draw my line moving away. It's silly, but that way I don't forget the rule, okay? So away from the positive, away from the positive, away from the positive, and towards the negative. Okay, so go ahead and do that. Make sure that you've got your arrows in the right direction. And then we will do opposite charges. And then then you can practice. If you already know what's going on, then go ahead and fill out your drawing. But try that first one. Make it look like mine. So many of you have just drawn random charges. Okay, so fix it, make it correct. Make your drawing match mine. That's why we're doing this. We're taking time to make sure that you're drawing these the same way I do mine. Let's do like charges. I'm going to switch colors because it's a little easier to see actually than the red. So negative charge, they go towards the negative, towards the negative. Okay, that's how they normally go. However, there's another negative. Negatives repel. So the field lines are actually going to bend away from the other negative. Field lines are going to bend away from the other negative. Okay? Bend away, towards, towards, towards. But all of these arrows are pointing towards the charge. Okay? So notice this. When I do the positives, the lines will look the same. So the pattern of lines will look the same, except the arrows will be pointing in the opposite direction. Okay? Because the field lines move away. All right, and then we have this one, positive to negative. I really try hard to draw my lines in the direction they actually move, and then add the arrows to, away, away, away. Okay, so make your drawings correct to match mine, and here in a second, I'm going to give you some practice where you're going to do this on your own. So someone's drawn the arrows for which way they're going to go, because that's all you've drawn is the one arrow. That is actually still what's going to happen with how they're going to move, but I'm wanting to see what the field line looks like, okay? Because we're going to draw field lines for magnetism, and actually how the field lines work is actually how electric current flows. It's how your power generator creates electricity. It's actually tied to how your speakers work and how your headphones work. All kinds of applications are based on how these field lines actually work. So I know we're doing basics and it may not quite make sense, but it's hugely important to deeper applications of these things. Let's try some on our own. Here's another set. Draw the field lines for these sets of particles. I forgot to talk about the bottom two rules. But those are the rules we're drawing these by. Positive field lines go away. They go away from the positive. They go towards the negative. Opposite charges, the lines connect. Like charges, the lines disconnect. They do not connect. Okay, I think I've completed my versions of the drawing. So if you're not sure how to do it, then you can check your answer. I know that's tedious. It takes some time to do it, but it should look exactly like mine. If yours does not look like mine, then yeah, we got some problems. And then also, I know, don't forget the arrow directions. Arrow directions are everything. Still several of us not drawing it correctly. Make sure that you are copying what I've got. Last thing before we move on from this is I really want to make a point of these are the field lines, but if I were to ask you, okay, well now draw which way these particles are going to go, that would be a separate drawing. That's a different line, okay? It might be pointing in a similar direction, but it is a different line. So which way would these particles move? That's a different drawing. So be careful of that, okay? So some of you are drawing the same drawing for this. Field lines are connected to that idea, but they're not the same thing. So which direction is it going? Opposites attract, like repel. Which way do the field lines go? Positive charge, the field lines go away. Negative charge, the lines go towards. If they're opposites, the lines connect. If they're alike, the lines don't connect, okay? So those are the rules you should be using. Okay, let's move on. If you have questions, please be asking those in the chat. Oh, all right. And yes, we are almost out of time. Okay, so tell me one question you have, okay? And none is not a valid answer at this time. Tell me one question you actually have. Could be about this content or about anything in general. And then tell me one thing you have learned in the last week or so. Do that in the Pear Deck for me. I'm going to turn it to student paste so you can go back and take a look at things. And I will also be editing this as a video and posting it so you can go back and re-explore the field line part of it. So great question. How would field lines work when there are more than 3 molecules? Guess what? You're going to learn about that on Wednesday and Thursday. So excellent question. The actual physics principle is called the superposition principle. And when you learn about Coulomb's law, we basically, Coulomb's law for first 2 particles plus Coulomb's law for the second 2 particles, and it all adds up. And we're not going to do this, but you can do geometry and all kinds of stuff to figure it out. You need to know how to do them. For all those lines we had to draw, you need to know that process because the magnetism lines are going to be very similar. On your quiz, you're going to be given a set of lines and you're going to have to go, yep, that's drawn correctly. Nope, that's wrong. Nope, that's wrong. Yep, that's correct. So yes, humans are 99% empty space. You are mostly empty space. So why do opposites attract? The true answer to that is because they do. That's the one part of science that sometimes makes it difficult is we observe this happening, and so we describe it by labeling these as having opposite charge. And when we do that, guess what? It works every time we see something with the quality of charge and there happen to be opposites they attract. It happens that way. Yes, come to tutorial time if you need more help. Okay. And protons, neutrons have different charges because of what they're made out of. Quarks, and quarks have charge. Molecule system max. I'm not sure what you're asking there. Okay, good questions. Keep those coming. I will also be filtering some of those to talk about later. But get those answered. Have a great week. You are free to go, and I will see you on Thursday.